Hello everyone. Today we will talk about Google maintain big data. First, what is big data? Big data is simply a collection of data that may be accessed to disclose patterns and trends. It is used by several multinational companies to filter the data and business of various companies. Let's talk about why Google uses big data. Google uses big data to understand what we want from it based on several parameters such as search history, locations, trends, and many more. After that, it goes through an algorithm where complex estimations are done, and afterwards, Google easily shows the arrangement or position fixed index list as far as significance and authority intended to coordinate the user's prerequisite. Google easily shows the ranked search results in terms of relevance and authority formulated to match the user's requirement. Google has acquired some techniques to understand users' requirements like index pages, real-time feeds, sorting tools, knowledge graph pages, literal and semantic search, Google Translate, and etc. First is Mesa. Mesa is a scalable analytic data warehousing system that stores critical measurement data related to Google's internet advertising business. Mesa is designed to satisfy a complex and challenging set of users and systems requirements, including near real-time data ingestion and queryability, as well as high availability, reliability, fault tolerance, and scalability for large data and query volume. Mesa handles petabytes of data processes millions of row updates per second and serves billions of queries that fetch trillions of rows per day. Mesa is geo-replicated across multiple data centers and provide consistent and repeatable query answers at low latency even when an entire data center fails. Second is Google File System. Google File System is a scalable distributed file system for large distributed data intensive application. Google File System is widely deployed within Google as the storage platform. Google File System is designed to accommodate Google's large clusters requirements without burdening applications. Files are stored in hierarchical directories identified by path name. Google organized the GFS or global file system into clusters of computers. A cluster is simply a network of computers. Each cluster might contain hundreds or even thousands of machines. Within Google File Systems clusters, there are three kinds of entities. First is the clients, second is master servers, and third is chunk servers. So what is client in GFS? Client refers to any entity that makes a file request. Requests can range from retrieving and manipulating existing files to creating new files on the system. Master servers act as the coordinator of the cluster or for the cluster. Master's duties include maintaining an operation log which keeps which keeps track of the activities of the master's cluster. The master server also keeps track of metadata, which is the information that describes chunk. Chunk servers are the workhorses of the Google file system. They are responsible for storing the 64 MB file system. Next is Bigtable. Bigtable is a distributed storage system for managing structured data that is designed to scale to a very large size, petabytes of data across thousands of commodity servers. Many projects at Google store data in Bigtable, including web indexing, Google Earth, and Google Finance. In the diagram, it illustrates all clients' requests go through a front-end server before they are sent to a Bigtable node. The nodes are organized into a big data cluster, which belongs to a Bigtable instance, a container for the cluster. Each node in the cluster handles a subset of the request to the cluster. By adding nodes to a cluster, you can increase the number of simultaneous requests that the cluster can handle, as well as the maximum throughput for the entire cluster. If you enable replication by adding a server cluster, you can also send different clusters, and you can fail over to one cluster if the other cluster becomes unavailable. A big table is sharded into blocks of contiguous rows called tablets to help balance the workload of queries. Tablets are stored on Colossus, Google's file system, in SS-table format. An SS-table provides a persistent, ordered, immutable map from keys to values, where both keys and values are arbitrary byte string. Each table is associated with a specific Bigtable node. In addition to the SS-table file, all writes are stored in Colossus shared log as soon as they are acknowledged by Bigtable, providing increased durability. Fourth is Google Flume. Flume Java is a Java framework developed at Google for MapReduce computations. MapReduce enables distributed computing, but not all real-life problems can be described using a MapReduce task. Instead, most of the real-life problems require a chain of MapReduce tasks for complete processing. This requires intermediate code to pipeline MapReduce tasks. Fifth is Google Millwheel. Google Millwheel is a framework for building low-latency data processing applications that is widely used at Google. Users specify a directed computation graph and application code for individual nodes, and the system manages persistent state and the continuous flow of records, all within the envelope of the framework's fault tolerance current. Millwheel's programming model provides a notion of logical time, making it simple to write time-based aggregation. Millwheels was designed from the outset of fault tolerance and scalability in mind. In practice, we find that Millwheel's unique combination of scalability, fault tolerance, and a versatile programming model lends itself to a wide variety of problems at Google. Google don't store each user's data on a single machine or set of machines. They distribute all data across many computers in different locations. Google chunks and replicate the data over multiple systems to avoid a single point of failure. And that's all. Thank you and keep safe.